Hello and welcome to video 22 in my Rigging in Maya series. In the previous video we began writing a script which will automatically rig a quadruped limb for us. We'd got to the point where we'd created all the main joint chains, so let's continue that now as we add in the ik and afk functionality. Because we are picking up directly from video 21, I would highly recommend you go back and watch that tutorial before starting on this one. Before we get started, I wanted to mention that you can download all the source files for this and all my other courses from my QBrush, Coffee, Gumroad and ArtStation pages. So there's plenty of options for you. You can find links on the screen and in the description below. I also wanted to tell you about the antCGi Club. Joining the club is a way for you to help support the future of this channel, as it will allow me to dedicate more time to creating new content just for you. But that's not all. You can also earn yourself exclusive rewards. These include all the course assets, models, rigs and custom made scripts, as well as access to the members only area of the antCGi Club Discord server. You can also claim a discount on all antCGi merchandise. There are two ways you can join. The first is to simply click the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon page and support me there. Alternatively, you can visit the link on the screen or in the description below to find out more. Okay, so here we are again. We have the dog model with the basic driver joints and some controls already added to the scene. And here we have Charcoal Editor, which is my scripting editor of choice, and this has the script we've written so far. In the previous video we set up the variables and built the foundations which our script will build upon. We were at the stage where we have automatically generated the base ik, fk, stretch and driver joint chains. So let's continue with a new section. What we need to do now is constrain the main joint chain to the ik and fk joint chains. This will allow us to blend between the two. To help speed things up, we can just use the same code here because this will go through each joint for us. We just need a parent constraint here. Let's check the flags. First we need some names. We can use the main joint name which is stored in joint hierarchy and simply add ik to it. We need to specify two more joints, so let's just copy this twice, remembering to put a comma in between them. Let's make this a bit bigger. Okay, so the second joint will be fk, and the final joint is the one we are constraining, so this will just be the base joint name. Finally, we need a couple of flags. W, which is weight, should be set to 1. MO is to maintain the offset. For this constraint, we need that to be 0. So this is going to take the ik joint and the fk joint and constrain the base joint to them both. Let's save and run that. If I find the base skeleton and look in the channel box, we can see it's constrained, and down here it's connected to the fk and ik versions of the same joint. Let's undo that again to get us back to the basic scene. In this scene I already have ik and fk switching set up, so we can use it to swap between the ik and fk controls. Something like this. Again, if you're not sure how to set this up, please refer back to my earlier videos, or download the source files and take a peek. Now we have the joints, we should make sure the FK controls drive the FK skeleton. Again, we can use the same piece of code because it's going through each joint for us. We can even use the parent constraint part too. We want the FK control to drive the FK joint. So let's change the IK part here so it matches the control names. Change this to FK_control and remove that last joint name. Otherwise we will end up with the FK control and the FK joint trying to drive the base skeleton. That's all we need to do. So in theory, these controls should drive the FK skeleton when done. Let's save and run it again. There, we can now control the FK skeleton. You can see the base skeleton is trying to stay between the IK and FK skeletons. Great, that's the FK set up. Time to look at the IK. We know from my video on quadruped limbs that the front and back legs are set up differently when it comes to IK. First, let's check if this is the rear leg and add the IK handle. If is rear leg, and we just need the IK handle command. Plus its flags here. First we will give it a name. It's always good to name things as you go, especially when scripting. Let's just use limb name, which we defined earlier, and add driver IK handle to it. Now we set which solver we need. What we need to do this time is refer to the documentation, so we know what we should add. We need a rotate plane solver, so that's IK RP solver. Next we tell it the start joint and the end effector, which is essentially the end joint. We can use joint hierarchy again, as this is a list of the base joints. But because this isn't in a for loop any longer, we can't use the I. Instead, we need to specify what joint we need, and as this is the first joint, we can just put 0. We also want this to connect to the driver skeleton, so let's add that to the name too. Let's duplicate that and use it as the end effector, as it's the same joint chain. And we need the last joint this time, so let's change 0 to 3. Ah, we have an error. And we can run that. Ah, we have an error. I put a capital S in solver. So let's just change that. And there we go, Maya crashes. Okay, just get back to where we were. Okay, so we were about to run the script again. There we have the IK handle. I'll make sure IK handles are actually visible. So there we can see it's manipulating the driver skeleton, which is exactly how we need it set up for the rear leg. Let's undo again. So next we can create the main IK handles for the limbs, and these are the same on both the front and back legs. I can just copy this and edit it. We remove one of the indents too, so it's not just running in the section above. Let's call this one knee IK handle. and this is going to be connected to the IK joints, not the driver joints. So we can change those names. And this one isn't going all the way to the end of the leg. Instead, it's just going to the metacarpus. So we can change this number to 2 instead of 3. We now need another IK handle for the bottom of the limb. This will give us that hock control. So let's duplicate this, and we can edit this again. Change the name to hock. This time we only need a single chain solver, so we can change RP to SC. And this one is going from the 3rd joint on the list to the 4th. So this needs to be 2. And this one 3. Makes perfect sense. Just remember that list numbers begin at 0. With the IK handles in place, we need a group. This will act as the pivot point where the hock control will rotate around. To create a new group, we simply use the group command. Let's check its flags. First, we will specify what we are grouping. Not this one. We want the knee IK handle. So let's copy that name down here, and let's give the group a name using the N flag. Let's call it the same, but change IK handle to control. I'm going to copy this line now for the second group. So we are grouping the knee control group now, the one we just created. This is just going to be an offset group, so we can use 0 rotations on the main group. We can just add offset onto the end of the new group's name. OK, quickly save and let's run the script. You can see we now have the groups. The problem is the pivot is in the wrong place. We need the hock to move forwards and backwards, something it won't do with this pivot point. Well, it will, but it won't look right. Actually, let's change this comment as we are using the group for the hock, not the knee. If we were to do this manually, we would just press insert and then snap the pivot to the ankle joint. A bit like this. But we need to automate it. OK, quickly undo everything. First, we need to know where the ankle pivot is. To do this, we can use a new command. This one is xform. This is great for getting and setting positions of nodes. There's a lot more you can do with it, as you can see from all its flags. If we look at the command reference, you can see all sorts of references to matrix coordinates and things, which may seem a little intimidating. Don't worry about any of that for now. We just need to use it to set our pivot point. The first thing we need to do is specify the joint, or the node we want to get the coordinates from. So we can use the joint hierarchy list again, but this time we want to reference the last joint in the list. So we can change this number to 3. Next, we use the Q flag, which is a query flag. This turns it into query mode, so it will find some information for us. After that, we want to specify that we want to pull the world space information out of it. This will give us exact position values. Finally, we want the pivot position. One thing I haven't mentioned yet is that instead of using 1, you could use true or false when setting flags. 1 would be true, false is 0. It doesn't really matter which you use. I guess using words is easier to read though. I wonder if I can run this. No, OK. It needs to run the whole script to work, so it knows what joint hierarchy is. So what this will do is find the pivot location and store it in the ankle pivot variable, so we can use it later. We can now use the xform command again to set the pivot point on our groups. We are working on the knee control group, so we can specify that first. And we want to update the offset group too, to keep things consistent. Because we are working on multiple groups, we have to put these in parentheses too, or the command might get confused. Add a comma and then the world space flag. And now set the pivot. We need to specify 3 values here, the X, Y and Z positions. These need to be in parentheses too. In the previous line, we found the X, Y and Z positions of the ankle joint, so we can just use that information here. Copy and add the ankle pivot variable. Because this is a list, we can reference the elements we need using brackets, just like we have been doing with the joint hierarchy list. All we need are the first three numbers that are stored in it. So the first can be 0, the second can be 1, and the third is 2. Let's run this again to check it's working. We have the offset group selected already, and we can see its pivot is at the ankle, which is perfect. The same with the control group. Okay, good. Undo again and move on to the next step. We now have to work on the hierarchy and make sure everything is parented where it should be. Let's check if this is the rear leg first, because if it is, we need to use the driver leg. We can use the same bit of code as before to check which leg we are working on. Now we can use the parent command to parent the knee control offset group to the third driver joint down the leg. We parent it to the driver joint so we get more natural motion in the hind leg. So we can copy this over and change IK to driver. It's already set to 2, which is the third joint in the list. Actually, I missed a step. We need to parent the hock IK handle and group it to the new paw control. I'll just copy this line and copy the hock IK handle name here. We need to add the paw control name at the end. If you remember, we set this up at the start, so we can just add that. Here we go, the paw control name. And add that to the end. So the knee control offset group and the hock IK handle will be parented to the control. I'll update the comment too, so it's more accurate. Now everything should move with the control. Okay, let's get back to the IK handles. If we were working on the rear leg, we have to parent the IK handles to the driver skeleton. I'll copy this line here. And we need to parent the hock IK handle to the third joint in the list. So that's the ankle or metacarpus. I can just copy this line. This time we are parenting the driver IK handle. So this is the one which runs the length of the driver skeleton. We can remove that. It needs to follow the paw control, so we can leave this here. Let's give this a try, see where we're at. Remember to hit Ctrl and S to save. What we should see is the IK leg following the paw control, and it does. If we find the knee control group, although this should really be called hock control group, anyway, we can rotate that to adjust the hock angle. What we can also see is a paw rotating with the hock too, whereas we need it to stay steady, so let's fix that next. Okay, undo again. First we will add a comment. And I know I'm going to be using an Orient Constraint, so I'll just copy a line I used earlier to start me off. This should do. I know it's parent constraint, but the command is pretty much the same. Okay, change this to Orient. What we need is a metacarpus IK joint to be constrained to the paw control. So I'll paste the paw control name here. And we need to specify the joint after it. So we will use this. Change driver to IK because we want to influence the IK joint. Finally, I'll remove this because we want to maintain the offset. If we don't, we might get some flipping. Okay, that should give us control over the paw. What next? Ah yes, the knee control. All we need is a pole vector constraint. Again, we have to handle the rear leg differently, so we can add in the check again. If is rear leg. We add a pole vector constraint. we need the knee control name, and again, we set this up earlier. So I can just copy this and paste it here. If this is a rear leg, we want to control the driver skeleton IK handle. The name is here, so I can copy this over. This just saves typing everything. Besides, I always misspell things when I'm typing, so copying and pasting means you get the correct spelling each time. And set weight to 1. Okay, I'll copy this line. We can use else here, so if it's not the rear leg, we can do this instead. And paste. All we need to do is direct the pole vector constraint to the knee IK handle instead, because the front leg doesn't need the driver skeleton. Let's save and run that. Great, works like a charm. The back leg is coming along nicely, so what about the front leg? We've been focusing on the back leg all this time, so let's try the script on the front. In theory it should still work because we've been thinking ahead and adding in areas which check what leg we are working on. First, we need to remember to set isRearLeg to 0. OK, select the route and go. Fingers crossed. So, no errors, which is good. Let's try the paw. Everything moves OK. Nice. Let's go back to the rear leg, remembering to set this back to 1. Time to set up the hot control, which is pretty much the last section we need to look at in this video. I'll add a new section and update the comment. So how this works is as it translates, the control group with the IK handle inside rotates, giving us that nice movement we need. To do this, we're going to enlist the help of a couple more commands. The first is shading node. What this allows us to do is create nodes like condition, blend colors, and what we need, multiply divide. First we need to specify the node we want to create, and the spelling needs to be exact for this. Next, we use the AU flag, which will classify this as a utility. Finally, we give it a name. Let's copy this to keep things consistent. And change the end to hoc multi. What this node will allow us to do is take the translations and convert them into rotations, while also being able to adjust the values. This means we can get the exact rotation we need. The next new command is connectAtta, or connect attribute. We use this to basically connect one attribute to another. Let's grab the hoc control name. We need the translate attribute, which will connect all three, X, Y and Z. So we just add period translate to the name. All we're essentially doing is building the name that the command will use. The translations from the control need to go into the multiply divide node. Let's copy its name and add it here. This also needs an attribute adding. I know from experience that this is input 1. If you're not sure, you can always open the node editor and connect things manually first. I'll run the script first so we can see everything up to this stage. So here we have the control. If I graph this, we have the multiply divide node connected to the control, which is what we've already done in the script. I'll open these and break the connections. If I connect it again manually, we can check what's been output in the script editor. You can see here we have the mel command, and the input1 attribute on the hoc multi-node was connected too. So, like I said earlier, if you're not sure of anything, do it manually first and then see what Maya spits out. Okay, let's go back. I need to add a flag to the end of this, f equals 1. This will force the connections, which is useful just in case something else is connected by mistake. Okay, on to the next connection. I'll copy this line. We now need the connection to come out of the multiply divide node and into the knee control group. I'll move this name here. And change the attribute to output Z. This is going to be connected to the knee control group's rotate X attribute. And we just want the output this time, going into the knee control group's rotate X attribute. Now those attributes are flipped for a reason. When going from translations to rotations, you will need to play around with the configuration to make sure things move as expected. Okay, on to the next connection. And we just want the output X this time, going into the knee control group's rotate Z. If we run this now, looks like I missed the underscore from the names. Let's try that again. That was it, great. Goes to show how important names are. We can see the hoc moving, but it's not enough. Also, it's inverted when moving along the x-axis. At this stage, all we need to do is play around with the values in the multiply divide node until we get the correct movement. We can then transfer this to the script so it's done for us. Let's move this out slightly so we can see the leg move as we adjust it. I'll adjust input to x. To get it to move the right way, we have to use a negative value. Okay, let's try minus 2.5. That looks better. Let's look at the Z translation. Maybe try 2.52. Looks okay too. So as we did that, you will see that Maya added the code we need with the setAtta command here, which is essentially set attribute. All we need to do is copy that but convert it to Python. So commands period setAtta. There you are. So looking here, we need the name of the attribute first. We pretty much have it here, so I'll just copy this and change output Z to input to Z. We then add a comma and the value we want to change it to, so 2.5. Let's copy that and update it for the input X attribute. And remember, this value needs to be minus 2.5. Okay, undo again. And as you can see, there's a lot of undoing and redoing. Imagine having to undo each and every line at a time. Let's run this again. So the leg moves with the paw control and the hoc control works perfect. We have another issue though. The main joints aren't following either the IK or the FK legs. They are floating between them. This is because we haven't added the blending ability yet. Let's do that next. We have the blending attribute here, and it works with switching between the controls, just not the joints. Okay, I'll add another section. And because we need to work through each joint in turn, we can bring the I for range code back into play. We know that will work for us, as it has so far. Each joint has a constraint node on it, and it's this which we need to blend between the two joints. So first we need to find out what the constraint is called. We can do this by using the list connections command. This does exactly what the name suggests and lists everything connected to the joint. We need it to check the joint, so let's use the joint hierarchy list again. And change the number to I, so it's dynamic and will update each time the loop runs. And this means it will go through each joint in the chain. Now we can list what type of connections we want to list, just to narrow things down. What I'm going to do is print that list for now so we can see what it gets. So if I run this, you see here we have a list for each joint. A lot of these are repeated because there are multiple connections coming in from the constraint, but we can just use the first in the list as we did earlier using brackets. If we run this now, you can see we just get the one constraint, which is much neater. Now we have the constraint name, we need to find the weights. These are the values here, which you use to blend between each joint. We can use the parent constraint command again, but this time use the query flag. We also need the WAL flag, which gives us the weight alias list. Now we have those weight names, which are just the attributes, we can connect them. Add a new connect attribute line, just copy from above if you like. If we go into the node editor and graph the left leg rear control, we can see the FKIK reverse node here, which is used to blend between the IK and FK controls. We can reuse this for the parent constraint weights. We also need the FKIK switch attribute here. Again, if you're not sure about this setup, please check out my earlier videos on IK and FK limb setup. Now we need the main control name, the one with the IK-FK switch attribute. Let's add this at the beginning here and change this to FK-IK switch. This is first because it's going to drive the second attribute we add. For the second attribute, we simply need to use a constraint name and add the weight after it using our getWeights list. Because this is a list, we need to specify which item in the list we are using. So using brackets, let's specify the first. If this is the wrong way around, we can always change it later. We also need to add a period between these so the syntax is correct. Let's copy this and connect to the second weight attribute. This time we need to use the reverse node. Let's check its name again. Okay, I'll copy that to be safe. Luckily the beginning is the same as our limb name. And paste it here. And remove the beginning because we already have that part of the name. We also need to add the attribute on the end. I already know it's output X, so I'll add it here. And we need to change the weight from the getWeights list to 1, so it's using the second weight. So let's delete that, we don't need it anymore. And run the script. You see now we don't have the 3 limbs with one floating between them. The main joints are locked to the IK leg. Let's hide these so we can see things better. So that's the IK leg. If we use the switch, it blends between IK and FK now. Okay, that's great. All we need to do now, for this video anyway, is update the hierarchy. First, let's create a main group to put everything into. We can use the group command again and use the em flag, which will leave it empty for now. And let's give it a name. Just something basic like _group. Now this group is going to control the upper leg, so we need to play around with its position. Luckily we've done this before, so I'll cheat and copy these lines here. We want the group to match the transforms of the root joint, and this is already pretty much set up to do that. All we need to do is change the new joint name to the group name. We can do the same with the line below, which will freeze the transforms on the group for us. Actually, let's change this to root joint instead to simplify things. We also need to freeze the transforms, so change the T flag to 1. If we run the script, we have the group and it's in the right position. What we need to do next is put all these joint chains into that group. Let's undo first. We can just use a parent command and then add all the root joint names first, so IK, FK and stretch. And then we add the group name last, because that's what we are parenting them to. We have another joint chain that are the driver joints. As this is only used on the rear leg, we can use the check again. If it is a rear leg, parent the driver joints too. Finally, let's move the new group to the rig systems folder so everything is kept neat and tidy. It's always good to clear the selection too at the end of your scripts. That is unless you need something to remain selected. Okay, let's run this again. Ah, an error. I spelt commands wrong. Not a problem, as that's at the end of the script. That's the rear leg set up. So now we need to add in the root control. Let's undo again. And let's put this in here. All we need is another parent constraint. We're using the root control. Another name we specified at the beginning. Oops, where have you gone? Come back. Maybe I should whistle. We need the root control to move the main group, and this will then move the joints inside it. Just add those flags again, weight 1, maintain offset 1. Because the group and the control are orientated differently, we need maintain offset, or the group and the joints inside it will flip. Let's save and see what happens. I need to fix that command spelling. Now we can use the root control to manipulate the top of the leg. We also have hock control, paw control, and we can point the knees. IK and FK blending works too. Okay, throughout these videos we've been focused on the left leg, so let's try the opposite side. Because we added in the section at the beginning of the script which checked for the prefix, it should just work. Let's see. Fingers crossed. Oh, that's commands again. I keep forgetting to fix it. There we go. Undo and retry. That's better. Let's see if the leg works. Great, works well. Okay, now let's try the front legs. But first we need to set isRealLeg to 0. Here we go. That works, although the hock control needs some adjustment. The values on the multiply divide node need to be different to the rear leg. Let's try the right leg first, make sure that works. Okay, it works, but again the hock needs adjustment. Let's see what values work. So 5 for input 2z. This way looks okay actually. Undo everything. Let's jump back to the section of the script where we set those values. Again, we can use a rear leg check. And we can use another variable. Let's set this to 2.5 because that value worked on the rear leg. We can then use else again if it's not the rear leg. And set multi-value to be 5 this time, as that worked better on the front leg. What we need to do now is use multi-value down here in our set attr commands, so it will set a different value depending on which leg it's working with. The problem is input 2x needs to be inverted. That's an easy fix though. We just add times -1 after it and it will invert that value for us. Okay, let's try this again. Hang on, where's the multiply divide node? Ah, we had it set to front leg. Okay, let's change this and try again. There we go, the right values and everything works. Let's do the right side. That works too. Now the front legs. Just update this. Correct values here. And that works much better. Onto the right side. Perfect. Everything is organised nicely too. Okay, so I think we've come at a natural place to end this video. We now have a script which will quickly rig all 4 of our quadruped limbs for us. This is going to save a lot of time in the long run, and with what you've learned so far, you could easily adapt this to make your own automatic biped rigging tool too. Although this is a good starting point for this limb, we do want to push things further. So in the next video we will expand upon this script and add in squash and stretch and also roll joints. Well, we've come to the end of another video. Thanks for watching right to the end, and if you found this video useful, please hit that like button to show your support. While you're at it, you could also subscribe and enable notifications so you're kept up to date with future videos and community posts. If you have any questions or suggestions, please post them in the comments below or contact me through the antCGi Club Twitter account and I will try my best to reply. Alternatively, you could post them in the antCGi Club Discord server where I spend more of my time. You can find an exclusive invitation to join in the description below. Remember that you can also join the antCGi Club to help support future videos while also earning exclusive rewards. Alternatively, if you would just like to show your appreciation, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again, this is antCGi signing off and I will see you on the next one.